All right, so today I want to go ahead and jump into section 2.5. We're going to be looking at graphs of sine and cosine. And before, I think I mentioned how the wrapping function works in tandem and creates actually sine and cosine curves. This was from the last section, but I wanted to show you what that specifically looks like. It's actually just this. So down below over here, you've got your wrapping function. Okay, so it's moving around the unit circle. And what's happening is you're measuring both the distance in x and the distance in y, and it's all based upon the wrapping function. So that's where we generate the curvature for both the sine and cosine curves that you can see right here. So it's almost mesmerizing when you watch it how it works. But this is kind of the idea of what sine and cosine are based upon. It's based upon distances of x and distances of y as they relate to the curvature of the wrapping function. So what I want to do now is I want to go ahead and jump into the notes here really quick. We're just going to go through a couple of pieces here. Majority of what we're going to be working on today is, again, just some examples, but I hope that as we go through these notes that they'll really resonate as we go through them. So first we're going to start with sine. Sine's usually the first one that it's the most common one that you see, I'll say, the sine function. In the textbook, I do want to point out there's quite a few tables and graphs and charts and stuff that are really, really handy to look at. So please take a look at table 2.7 on page 169. There's so much information regarding both of these curves that they are really, really handy and will really play a huge role in you helping you understand what this is that you're looking at. So take a look at those tables, the figures. Really, if we're looking at from 0 all the way up to 2 pi, this is what this curve is going to look like. So the basic y is equal to sine of x is going to start at 0. When you get to pi over 2, I don't have it charted here, but pi over 2 would be the maximum of this curve right here. Pi, it's going to be 0. At -1, this will take place at 3 pi over 2, and then we're going to have 2 pi. It's going to be 0 again. So you just have this what's called periodic function. It's going to continue along this very same trend. So what you see here, where it increases and then decreases, it continues like that in perpetuity. In other words, it continues like that forever. And it does the same thing in the positive direction, but it also does the same thing in the negative direction. So you can imagine, since it's continuous, it'll jump down here and then go up and then back and so on and so forth. So this is a periodic function starting at 0. Here are some of the basic properties. I do want to point out some amplitude and period. The amplitude is just going to be half of the maximum y value minus the minimum y value. So notice on this one right here, okay, the maximum y value is going to be 1. And I'm subtracting a -1, okay? The -1 down here is the minimum. So that's the thing that's important about this, is that you're subtracting a negative in this case, which means that it's adding. So you have 1/2 of 1 plus 1, which is 2. 1/2 of 2 is going to be 1, so that means the amplitude of this standard sine curve is just going to be 1. The amplitude is usually represented as a, so it sits in front of the curve or the function. So you've got y is equal to some letter a, which we call the amplitude, times sine of x. And the amplitude is literally just going to be the absolute value of whatever this value is, if you see it. If you're trying to find the amplitude by looking at the graph, you can do it just based on what I showed you here. But if you're just trying to find the amplitude based on the equation, it's always going to be the absolute value of the number that sits in front. So if we have y is equal to -3 sine of x, the amplitude is just going to be the absolute value of -3, and the absolute value of -3 is going to be +3. The period of this function is where the cycle basically repeats itself. So it goes in both directions. And specifically for this one, what you'll see when you look at, again, the graph, the period is going to be, in this case, just 2 pi. It's one cycle is where it goes up and then it comes back down. That is where the that's considered one cycle. So the period would just be whatever the distance is between where you started and where you end. So down here, again, if you're looking at it based on the actual equation, it's going to be related to what that value is there. So suppose I've got sine of 10x, okay? What I would do is then take 2 pi over absolute value of 10, which is just 10. So then I'd have 2 pi over 10, which is 1 pi over 5. So pi over 5 would be the period. Okay? Now cosine works pretty much the same way. It's almost identical. The only difference between sine and cosine is that it's shifted by pi over 2. So notice right here how the graph, it actually goes through 0 at pi over 2. We'll take a look back here. It goes through 0 at pi. So all we're doing is we're taking this piece right here and we're starting it backwards a little bit, okay? The graph at the maximum is going to be shifted to the left by pi over 2. So that's kind of what it is. Sine and cosine are related in that way, is that cosine is just shifted to the left pi over 2. Or you could think sine is shifted to the right pi over 2. It's again, it's all relative. So that's kind of the idea there. The amplitude, by the way, of the graph of cosine is identical. It's the exact same thing as it is for sine. So the amplitude, again, is going to be based upon the value in front. It's the absolute value of A, and it's also the gap between the maximum and minimum points divided by 2. So here you have the amplitude is going to be 3 of negative 3 cosine of x. The period is going to be pretty much identical. It's, again, exactly the same thing as it is for sine. It just looks a little different, so you just have to recognize that when you take a look at it. So what I want to do now, I do want to go through a few problems. Let me go ahead and pull up my whiteboard here. Give me just 1 second. All right, so what we're going to do here is take a look at just a few problems. So the first problem we're going to look at is question number 6. Let me actually turn to it so I can read it to you. Most of these problems are just recognizing amplitude, period, things like that. So let's just go ahead and remind ourselves y is equal to a sine of bx. Y is equal to a cosine of bx. A is going to be amplitude. And period, you use b to find period, but you actually, that is not going to be the period of it. So it's going to be 2 pi all over absolute b, okay? Or in this case, I should say the absolute a is amplitude. So the same applies here as well, okay? It's the exact same. All right, so now that we know that, let's go ahead and take a look at a problem. So let's look at number 6. Okay. So here they give us y is equal to 2 sine of pi x all over 3. Now, one thing I recommend doing is to try to mirror these equations similar to what the standard ones are up here. So you can see how it's b times x. Up here I've got the x in the numerator, but pi over 3 is just a coefficient. So you can rewrite this if you need to as 2 sine of pi over 3 times x. Okay, that way it just makes identifying those values for a and b a lot easier. All right, so in this case, let's just identify what those values are. A is going to equal 2, so this is the amplitude. And I probably should have stated this. The question is asking us to find the amplitude and period of the function defined. So the amplitude in this case is just going to be 2, and then b is going to tell us what the period is. So remember, the period is not b. The period is going to be using the value of b to determine what that is. So in this case, the period of this function is going to equal 2 pi divided by, what do we got? Pi over 3? So notice this is a, by the way, I made it just positive, pi over 3 with no absolute value because it's positive already, so there's no point. If it was a negative sign in front, I would have just made it positive. That's important to remember, okay? So now when we do something like this, when we have a complex fraction, the way to resolve the complex fraction is to multiply both the numerator and denominator by the reciprocal of whatever that thing that you're trying to get rid of. So here what I'm going to do is multiply by 3 over pi. And I'm going to multiply this by 3 over pi. And the reason why is because this 3 wipes out that 3, this pi wipes out that pi. So this is literally the same thing as 2 pi times 3 over pi, okay? Or another way to think about it is 2 pi over 1 times 3 over pi. That way you can multiply across. 6 pi over pi. These guys are going to cancel, so I'm left with a value of 6. So the period is going to be 6. So if you were thinking about it like this, what does it graphically look like? I don't know how I'm going to do this here. 3, 2, 1. Ugh, see my scale? I told you I'm terrible at drawing, guys. Let's try this one more time. Here we go. Let's do 3, 2, 1. Okay, that's not bad. 4, 5. I need my longer line here. And 6. So 6 is where the sine curve is going to end. And 2 is going to be the amplitude. So in other words, it shoots up to positive 2 and negative 2. Okay. So it looks like at 3 is where it's going to be at 0. So right around here, it's going to look like this. Like that. Okay, that's pretty decent for me. I'm not the greatest. So this is the same thing as, let's see, 2 sine pi over 3 times x. Okay, so this is 6. This is the period. That's one iteration of the curve. It has an amplitude of 2, which means it's its maximum height. So based on just some of the information that you have here, you can graph these, I think, hopefully pretty easily. Hopefully it makes sense. Hopefully my explanation is not just like you're probably like rolling your eyes thinking, dude, what are you talking about right now? I hope that's not the case. All right, so let's go ahead and do another one. Let's do question 15. Okay. Y is going to equal minus 3 cosine of 2x all over 3. Okay. So in other words, the way you can rewrite this is minus 3 cosine of 2/3 times x. So what we're going to do, again, remember my absolute A is equal to amplitude. So that's going to be absolute negative 3, which is equal to 3. So this is my amplitude. In other words, what that's saying is it's going to be positive 3 and negative 3 is the maximum values that will attain. And then the period, again, we're going to use B to find it. We're not actually going to be, I guarantee you this is going to happen. Somebody's going to do this in this class. They're going to say, oh, the period, it's just 2/3. That's all it is. It is not 2/3. Okay, the period uses 2/3 to determine that value. So you have to substitute in absolute 2/3. Okay, and then we'll go ahead and solve that. So again, we have a situation with a complex fraction. You multiply by the reciprocal. These are going to cancel, and that means that you have literally 2 pi over 1 times 3/2. Okay, so that's equal to 6 pi over 2, which is equal to 3 pi. Okay, so that right there is going to be our period in this problem. One thing I will mention, if you do have some problems that require you to go ahead and graph these on a graphing calculator, I think I showed you this before. Let me show you again, just because I think it is important for us to see it. Let me try to zoom in here. Give me just a second. We're just going to zoom in. Ah, that was pretty close. All right, so back up here. All right, so one thing I need you to keep an eye on when you're doing this, make sure that you go to mode, and you need to be, in this case, in radian mode, not in degree mode. Okay? When you graph, you need to be in radian mode. When you're trying to find the sine and cosine of, again, you need to make sure that you're in the correct mode. So if they give you degrees, obviously you switch it to degree mode, but most of the time, again, we're going to be using pi, 2 pi, pi over 2, 3 pi over 2, things like that. That's always going to be in radian mode, so you need to make sure that whatever the question is asking you, you're switching to the correct mode based upon the context of the question, okay? All right, so let me go ahead and jump forward here. Oh yeah, by the way, let me just do one of these. I want to show you what this looks like. I'm going to go back and pop this in here. Okay. So I'm going to go to radian mode, which I'm in. And to graph these, you go to y equals, and I've apparently got something else in there. Let me get rid of it. So I'm going to do question 50. Question 50 says 1/2 sine of 3x, but there's an absolute value around it. So if you're probably wondering to yourself, where do I find the absolute value? The answer to that is in this button right here. It's called math. So we type that in, and you go right here. There's the ABS. ABS, you hit that, and then you punch in your function. So this is going to be 1/2, 1 over 2, times, you don't need the times, I guess. I mean, it's probably okay. Either way is probably okay. Sine of, in this case, it's going to be 3x. The x, the variable, is that little button right there. You can see the x, the t, the theta. If in case you were wondering, that's a theta. And the n. Close it off. Close it off. So there's 2 brackets. There's a bracket right there for the absolute value, and then the other bracket which closes the 3x. Okay. So for this guy, I am going to go ahead and set my window to, what do I want to do? Let's do -1 to, yeah, we'll do 6. That's fine. And then we'll do, let's see, the amplitude is 1/2, so I don't have to go that high. I'm going to go -1 to 1. And we'll see what happens. Ah, there you go. Look at that. Oh, man, my calculator. I think the batteries died on this thing. Yep. Probably going to die again. But you can see what happens, right? Normally, where the curve would drop below the axis, it actually shoots back up. So it looks like you just have a whole bunch of little hills. That's kind of the idea with these absolute value functions. Remember, absolute value just says whatever's negative, just make it positive. So in any case where the function drops below the axis, all you're doing is you're putting it positive again. That's pretty much it. So that's how you would go about graphing something with an absolute value in it. All right, I want to do question number 58. We're going to go ahead and jump forward. So question 58. These ones are a little different, and the reason why is because they're asking us to find it's almost working backwards. Is find the function based upon the graph, okay? So let's try to do this. This is going to be a positive 2 and a negative 2. It looks like this is going to be boom, boom. Let's see, in between. 3 pi over 2, 3 pi. This is going to be 9 pi over 2, I believe. Yep. And 6 pi. Okay. And then, I need to graph the curve, of course. This is going to drop below there, and then it's going to shoot up there, and then I always have a hard time with these parts, the in-betweens. Hey, that's not bad. There we go. All right, so right off the bat, I can tell you that this, because of the way that it just looks, and it starts at positive 2 instead of 0, it's already going to be a cosine. Okay, so a lot of times what I recommend doing, graph it out, and then just kind of write down or jot down some of the properties. So in this case, it starts at positive 2, so it's cosine. Okay, so we know that, cosine. The amplitude, it's going to be 2. Amplitude is 2. Since it's the absolute value of the pieces, positive 2 and negative 2. Well, you don't even have to write that. You basically can say it goes between. The max and min are going to be positive 2 and negative 2. Since let's see here, max and min are positive 2 and negative 2. Okay. And then let's go ahead and take a look. How do you find the period? That is a good question. Okay, so the period, we know the period of this. Now remember, previously we had to use the b value to find the period, but now we know what the period is, so we have to find the b value. It's kind of backwards. So in this case, let's go ahead and take a look. We know that the period is going to be 6 pi. Okay. And we know that the equation for the period is that guy right there. It's going to be 2 pi over absolute b. So all we do is we set 6 pi equal to 2 pi over absolute value of b. All right, so now to solve this, well, we have to find the b, so let's invert everything. So 1 over 6 pi is going to equal absolute b all over 2 pi. And we can multiply both sides by 2 pi. Okay. That'll wipe this out. And that means that we have absolute b is going to equal 2 pi divided by 6 pi. Okay, so that's going to cancel. which is equal to 2 over 6, which is equal to 1/3. Okay? So absolute value of b is equal to 1/3. So the b value, b is equal to plus or minus 1 over 3. Okay? Because it's absolute value, can technically be either one. It doesn't matter. So there is, you'll notice in the instructions it says find an equation. It doesn't say find the equation, and the reason why is because of these absolute value signs. It could be one or two different things. And so what we're going to do then is just, I'll come over here and we'll write the equation. So we've got our b value. Our b could be plus or minus 1/3. Our period, so yeah, we found that based on the period. And then the amplitude is 2. So we have y is equal to 2 cosine, because that's the function that we're based upon. And we'll just use positive 1/3. Why not? Times x. And that's literally it. That is the entirety of that particular problem. So again, it's kind of like working a puzzle. You have to try to find the correct pieces and plug them all in. And it's helpful to be able to look at the graph to identify what's happening, to find the equation. Just as helpful to know how all of the pieces of the equation fit together to create the graph. So it's like in both directions, it's important to know that stuff. So yeah, anyway, that is how you would go about doing that particular problem. So if anyone has any questions, let me know. There's probably going to be a few of those like that on homework assignments. But yeah, if anyone has any questions, let me know. Hope you have a great day.